Hi there folks. This video is going to talk about how to solve a quadratic equation. Now, you've already watched a video that I've done before, and the video was about how to factor a quadratic equation. And so the question is, why would you want to know how to solve a quadratic equation when you have already learned how to factor one? Okay, so there's the question. Well, when you factor a quadratic equation, you're actually, like, let's say you come up with an answer like this. If you factor a quadratic equation, let's say you come up with an answer like this. If you were to graph this, what you would find is that it's a parabola. That's what a quadratic equation is. And what you're doing is you're finding the spots when you factor where the parabola cuts through the x-axis, this being the x-axis, okay? The only thing is, the parabola doesn't, if you were to, graph this in Desmos, this parabola doesn't cut through at -10 and 3 like you might guess. It actually cuts through the opposite of what you think, or what many people think, at 10 and 3. So let's say this is 10, and over here, this 3 here, it's actually the opposite of 3, it's -3. These are the two places that the parabola would cut through. Or these are called the, there's three words actually. There's x-intercepts, okay? Some people call them the roots, and some people call them the zeros, okay? All of these things, you're basically looking for these two spots, okay? When you factor something, you are finding these two spots. However, it's the opposite of what you end up getting. So instead of -10, it cuts through at 10. And instead of 3, it cuts through at -3. The word 0 is kind of a good one because you're actually finding the spot where this quadratic equation would equal 0. So what would you have to make x in order for this thing in the brackets here to be 0? Well, x would have to be 10 because 10 minus 10 is 0, and 0 times anything would be 0, okay? And likewise, if you were just looking at this bracket, x would have to be -3, and that would make everything inside here become 0. 0 times anything is just 0. So that's why the word zeros is kind of useful here. Well, let's get back to the question here. How do you solve a quadratic equation? You've just had a quick introduction. Let's actually do that right now, okay? So once again, remembering factoring, let's factor this. The x goes here and here, and this is assuming you've watched the video on factoring already. So if you feel you're completely out to lunch about what I'm doing here with these brackets, make sure you watch the video on how to factor a trinomial, okay? Anyway, two numbers that multiply to make -10, but add up to make -3. Okay, well, we know 5 and 2 will multiply to make 10. And as far as the signs go, we want it to be a -3 when you add these up. So it's going to be -5 plus 2, and that will work nicely. Okay, remember, we're finding the zeros here in this question because we want to know what are the x-intercepts. The x-intercepts always happen when y equals 0, okay? So I'm putting a 0 on the end there. And remember what I just did in the introduction? Well, the two zeros are going to be the x-intercepts, or the zeros. The x-intercepts are 5. I'm choosing the opposite of what I see here. And -2. We have just solved this quadratic equation. There's two answers. One is 5 and one is -2. By the way, in real life, when you're doing something with a quadratic, if you get an answer that's positive and one that's negative, the negative answer often won't make sense in real life. For example, when you're thinking about time, like a stone getting thrown, the -2, we call that an extraneous answer because it doesn't really make sense. There's no such thing as negative time in this case. And we would just say, well, the rock hit the water after 5 seconds. That would be an incredible throw, but anyway, you would keep this answer. When it's just a math question like this, there's no word problem. you would stick with these two answers and say, here are my two x-intercepts. Or, remember, what are the other words for x-intercepts? Roots. Or, what's the other word you could use? These are the two zeros. I'm never sure if I should put an E there or not, so bear with me, folks. I am not a genius. I'm just a humble dude that likes to do math. Okay, let's go to another question. This question is a little bit different than the last one because it is not a trinomial. It's actually called a binomial because there are two terms here, 3n squared minus 6n. Again, there is a video that I've done in the past on how to do this, so I'm not going to spend too much time talking about that, but let's factor this thing, just like we did in the past. Okay, remember, we're going to find the spots where there are x-intercepts. That's when y equals 0. And we're going to factor this. So you look at the 3 and the 6 and you say, what's the biggest number that could divide 3 and also divide 6? And hopefully you'll tell me 3. Okay? Because 3 times 1 will make 3. 3 times 2 could be 6. Is there I guess we don't have to, I'm not going to say letter. I'm going to use the math word variable. Is there a variable that both of these have that they could each give up? And they have to give the same amount. So is there a common factor? Yes, there is. Okay? There is a common factor of n. They both have an n. This guy has 2 of them. This guy has just 1. So anyway, that's another video, and I don't want to spend too much time talking about why that is, okay? Because I do have another video that talks about that stuff. Okay, we have factored out a 3n. Let's put what's left in the brackets. 3n times what would give 3n squared? Well, just n. 3n times n will be 3n squared. Now we've got a negative sign, so let's put that there. 3n times what would be negative 6n? Well, 3 times 2 is 6, and the n is already taken care of. 3n times negative 2 would be negative 6n, and we are done. We have factored this thing. But we haven't solved it. We haven't solved it yet. The way we solve it is say, what would n have to be for this whole thing to become equal to 0? Okay, what would n have to be? Maybe you can think about that right now, but since this is a video, I'll let you push pause if you want, but I'm going to go right to it. 3 times 0 is 0. So n could equal, or you could say the intercepts or the roots could be 0. What else could it be? Remember, it's going to be the value of n that would make this inside the brackets become 0. n minus 2, what would be 0? Well, 2 minus 2 is 0. So 0 and 2 are our roots, or our zeros, or our x-intercepts, however you want to call it. Okay? So those are what we were looking for. We have just solved for this equation right here, this binomial equation. Okay? Okay, so here we have a question that's a word problem. It's a real-life question, and that's where parabolas really take off. They're used a lot in real life, and I guess I don't need to keep telling you about that. You've seen the other videos. Okay, here's the situation. A rock is thrown straight down from a building that is 95 meters high. And here's the relation. Okay, h equals negative 5t squared minus 25t plus 95. That 95 on the end is, it's included here, and it's helping us figure out what we need to know. And it's helping us with regards to this building that is 95 meters high. So that 95 right here, we don't need to worry about putting that in the equation later. It's already being included here. Okay? Here's the question. Okay, I'll let you keep reading it, but I want to point out two things. The height of the rock is h, okay, and that's in meters, and t is seconds, okay? So the height of the rock is h and t seconds. Now see, there's an h right there, and there's a t right there. Actually, there's two t's, okay? So it's the question, how long does it take the rock to reach a ledge that is 25 meters high? Okay, so how many seconds would it take the rock to reach a ledge that is 25 meters high? So it seems that we know the height that we're looking for. The height is 25 that we're looking for in this situation. What we want to know is the time. How long would it take to reach that 25 meter height, that ledge? Okay, so here's how you'd write it. Instead of h, I am writing 25. Okay, and I want to know the time when the time equals 25 seconds. Okay, sorry, when the time equals 25 meters. So, sorry for that. Negative 5t squared minus 25t plus 95. I probably should be writing smaller. Now the first thing we want to do in a question like this is we don't just start factoring, okay? We have a 25 over here. We have to get rid of it, okay? What we're going to do is we're going to subtract 25 from this side. And remember in math, you have to do the same thing to the other side. I'm going to look for a place where there's a like term, and that's right there. 95 and 25, they can play nicely with each other. So we end up with 0 over here equals negative 5t squared minus 25t. Those t's are terrible because they look like plus signs. I apologize. Now 95 minus 25 is, well, 5 minus 5 is 0. 9 minus 2, there we go. So now we have the situation where we can factor this, but we're still not quite ready. Before we factor this question's not just a quick and easy one. I'm going to move this down so we have more room. Before we can factor this thing, it's good to get rid of what's in front of the t squared, okay? When I say get rid of, I'm actually going to factor out a negative 5, and hopefully it's going to work for this entire trinomial we have here, and chances are it's going to work in this particular math course, okay? So I'm going to factor out the negative 5, and let's see what's left over in brackets. Over here we'd have t squared, because this times this would be negative 5t squared. Over here we would have, well, it's a negative 5 we're taking out, so be careful. All the signs are going to become the opposite, okay? Well, 25 divided by 5 is 5. Or you could think of it this way. Negative 5 times 5 is 25, and it's a negative 25, so that works. And then we have over here a positive, oh sorry, that's a t there. Whoa. See what I mean about these t's? The plus sign is so easy to forget because the t and the plus sign look alike. I apologize for using such a terrible variable. I'm sorry, t, but you're just not very easy to work with. Okay, 70. What's 70 divided by 5? If you have a calculator, you can do that, or if you can do it in your head, even better. But we're going to get a negative sign, and it's going to be 14, because negative 5 times negative 14 is 70. Okay, finally, we are at the stage where we can factor this trinomial. Okay, let's factor it. We know the t, the lovely t, is going to go there and there. What numbers multiply to make negative 14 but add to make 5? Well, definitely 7 and 2 are going to be the numbers. What about their signs? Well, we want a plus 5 here. So let's make the 7 positive and the 2 negative, and then we've got ourselves a winner. Okay? Wiener, gagnant. Okay, that's what they say in Canada when you buy a lottery ticket. Okay, so we're at the stage now where we have factored this. But remember, this lesson, factoring isn't the end thing here. We actually want to know what are the x-intercepts, what are the roots, or what are the zeros. Okay, as we did before, don't worry about this negative 5 here. The answer still is just as easy as before. All you're doing is coming up with what would it take for this to be 0. If you're saying negative 7, you are right, because negative 7 plus 7 is 0. 0 times this times all of this over here would be 0. So the x-intercepts are negative 7 and, look over here, t minus 2. Well, do the opposite of minus 2, it would be plus 2. So we've got negative 7 and 2. Okay? Now remember what I said before. we've got a parabola here. And, whoa, we've got a parabola. I'm going to quickly draw it. The parabola is cutting through at -7 over here and at 2. Okay, and that rock is sort of in a parabolic arc. Gravity takes over. It's actually being thrown from a building, and this is where it all starts right here. I'll put a red line right here. It starts right here because this is where time is 0. Over here is where the rock lands. It's actually not landing on the ground in this case. It's landing at that 25-meter height. Because remember, up here we were concerned with a 25-meter height. Okay? So we're actually finding the spot where this rock is at 25 meters high. So that was 2 seconds. And can you see from this that the best answer, and again, a word problem, you should really have a word answer to follow up. You can't have a negative time. So this answer right here is really extraneous. This answer here is not needed. What we're concerned with is getting this answer right here, which is 2. So the rock, what could we say? The rock reaches the ledge. Sorry, this is pretty boring for you to watch this slow writing here. At, or you could say after, 2 seconds. Okay? You could make it even better and say the rock reaches the 25-meter high ledge after 2 seconds. But there's the big deal that the teacher will be looking for, is that 2 seconds, and the fact that you didn't say 7 seconds, because that would have been tempting. All right, I think we're done. And yes, there's more questions to go, and I hope you're feeling okay after all this. Okay, I should sign off before I make you any more upset with wasting your time. I apologize. Have a great day.